Welcome to the Visual COBOL in a Nutshell series of presentations. This module will cover how to establish a connection between your COBOL application and a relational database when using Visual COBOL's OpenESQL technology. So what exactly is a database connection? Well, a database connection is a communications channel between a client application and a database that may be located either locally or on a remote server. Connections under OpenESQL support transactions so that groups of SQL statements can be committed or rolled back as a unit of work. Connections also provide for user authentication against a particular database. User credentials are provided as part of the connection handshake, and the database sends back either a valid connection handle if successful or an error message detailing the reasons for the failure. Once a connection has been established, the client application can execute SQL statements against the database and have result sets returned to the application. Connecting to a database in Visual COBOL is a two-step process. The first step is to define a data source name, which provides the necessary connection information. Step 2 is to code the connection into your application. So step 1, defining the data source name, or DSN. There are a couple of tools available that can be used to create a DSN that COBOL can use to connect to a database. The first tool is the ODBC Data Source Administration tool. This tool is part of Windows, but Visual COBOL provides links to both the 32-bit and 64-bit versions of this tool directly from the Visual COBOL group under All Programs on the Start menu. This tool is used to create DSNs that use installed ODBC drivers for your databases. These DSNs can be used by Visual COBOL native code applications. If you are developing .NET Managed Code applications instead of native code, then you would use the ADO connection editor, which is supplied with Visual COBOL. These tools are covered in more detail in the presentations on using ODBC with Visual COBOL and using ADO with Visual COBOL respectively. An important note here is that you must be careful to ensure that you create 32-bit DSNs to be used in 32-bit applications and 64-bit DSNs to be used in 64-bit applications, as a 32-bit DSN will not work in a 64-bit application and vice versa. We'll take a look at each of these tools in a moment. So after you have created your DSNs, the next step is to code your application using the appropriate connection technology. There are several methods available for connecting to a database from a Visual COBOL application. The first method is to use an implicit connection. In an implicit connection, all required connection information is provided directly using compiler directives. You can specify your DSN in the DB directive and your user credentials in the pass directive if required. The init directive is then used to tell the compiler to connect using the DB and pass directives when the application is run. Implicit connections are only supported in native code, and it generally is not a good idea to use them, as all information is hard-coded and your application must be recompiled if any information changes. A better method of connecting is to use an explicit connection. In an explicit connection, an exec-SQL connect statement is executed, which contains necessary connection parameters such as DSN and user credentials. Several syntax formats are supported to ease migration from other systems such as Oracle Pro COBOL or Mainframe DB2. There are some formats where DSNs are used and others where they are not. Where a DSN is not used, all connection options are supplied within an embedded connection string. These are handy if you wish to store the connection information in a configuration file or elsewhere. In addition to explicit connections for use in .NET Managed Code applications, there are some extended connection methods that can be specified using exec ADO syntax. This allows you to share connections with programs written in other .NET languages, allowing you to pass the ADO connection objects between them. Let's take a closer look at what we've covered so far. Okay, so this is Visual COBOL for Visual Studio 2012. The first item I'll demonstrate is native code connections. To open up the ODBC administration tool, you go to All Programs, and under the Visual COBOL or Visual COBOL for Visual Studio 2012 group, under Data Tools, Data Connections, you have an ODBC Data Source Administrator, 32-bit and a 64-bit. You want to be careful to use the tool that has the bitism of the project you're creating. Here we're working with 32-bit, so I'll start that one. Under the System DSN tab, we've already created a couple here to use in our demo. We have two for SQL Server, one that uses SQL Server credentials when connecting. You have the choice of using Windows authentication or SQL Server authentication. This one uses SQL Server authentication, which means that a username and password have to be provided in the connection. Okay. The other one, the only difference is that this one uses Windows authentication, which means it authenticates against the users of your Windows machine. We also have a DB2 connection created. You can see that the screen looks a little bit different, and that's because each ODBC driver has its own set of options. So each vendor is specific to a particular database. Here we are supplying DB2 credentials, and we can test our connection here using the connect button. Okay. So these are the DSNs that we'll be using. The first thing that we'll show is the implicit connections. Okay. Now in our project properties, this is a native project. A couple things to look at. Under the COBOL tab, you want to make sure your platform target is specified to the bitism that you need, x86 being 32-bit and x64 being 64-bit. Okay, and that has to match up with the DSN type that you're using. There's also a SQL tab where you can set these OpenESQL directives directly. Here we're using DB manager equals ODBC. That's used for native code. You can also specify these directly in the program source, but here it's easier to do at the project level. Okay. For implicit connections, these are only supported for native code. All the connection information is specified in this directive, the SQL directive, using options of DB specifying the DSN, and pass specifying the user credentials, the username separated by a dot and the password. Okay, the init directive is what actually tells it to create a connection at runtime to connect to this data source. We run this. We can see there's no connect statement in the program. It's automatically connected when the program starts. Here we have a simple select statement of one of the tables in the Northwind SQL Server database, and all it does is select a category name and displays it. We'll use this same select statement in all our demos here, and you can disconnect it when you're done with it. Okay, that's an implicit connection. For explicit connections, for native code, we have a program here that'll demonstrate the various formats. We run this. In OpenESQL, we have the whenever SQL error phrase that you can use. Whenever this is set, if an error code comes back that says it was not successful, it will automatically perform the error paragraph. Here we'll test that by trying to connect to a DSN that does not exist. When we do that, it jumps into the OpenESQL error paragraph and gives us a message of data source name not found. Okay, and a SQL code of -19703. This is also the same code and message you'll get back if you try to use a 64-bit DSM with a 32-bit program and vice versa. Okay, we'll continue on. The first DSN we'll use in the connect is the one with Windows authentication. So all we need to supply is that name. We don't have to give it any other user credentials. And the connection's made and the statement's executed successfully. Okay, and we do a disconnect when we're done with our connection. Okay, for format 1, it's just a different syntax of doing the same thing. Here we are using the DSN that's not using Windows authentication, so we provide our username and password in this format here, separated by a dot. You can also use a slash to separate it, and you connect using these host variables. Okay. And disconnect. Format 2, slightly different format. Here you connect to your user credentials using the DSN name. Does the same thing. Disconnect. Here we're using an Oracle format where you connect to the username identified by the password and then using the DSN. All different ways of doing the same thing. Okay, here we have a connect with prompt. This format 3 is only available for native code applications for ODBC. When you execute that, it actually gives you a dialog screen where you can select the DSN that you want to use. This is very good for testing and developing, but I wouldn't use this kind of connection in production. You wouldn't want your user to be able to pick various DSNs to use. Here we use the one with Windows authentication, and we can see that now it's connected to our selected DSN. Okay. Format 4 doesn't really connect to a database, but it is a form of a connect statement. It does a connect reset, which is the same thing as doing a disconnect. Okay. Format 5 and format 6 use connection strings instead of just providing a DSN, so that you can have all your options that you want embedded into the string. Format 6, the same thing. It uses a little bit different syntax. Here you have connect DSN. Here you have connect using. Same end results. Okay, so that's native code. For managed code, we'll first show the connection editor. Now, the connection editor can be found in that same group as the ODBC administration tool. It's also located here under Tools, Micro Focus COBOL, ADO.NET Connection Editor. Okay, this is where you maintain your ADO DSNs. Here we have a couple corresponding to what we did with ODBC. We have 2 SQL Server connections, one with Windows authentication and one without. For ADO, that option is specified under the option for integrated security. Here we have it set to false, which means we have to provide a username and password. For the one with Windows authentication, we have the integrated security set to true. Okay, your other options in here are to the database name, data source, everything specified. A little bit different, but this is for ADO connections. Okay, so we show our managed program. It's very similar for the native for some of the options with some additional syntax that's supported. We can see in the managed code on the properties, you have to make sure that your platform target is set correctly. By default, any CPU is set when you create a new managed project. It cannot be used, any CPU cannot be used with OpenESQL for ADO. You have to specify x86 or 64, and then use the corresponding 32-bit or 64-bit ADO DSN. Okay. Your SQL directives are specified the same way, only a DBman uses ADO instead of ODBC. We'll run this. Okay, we use the same error handling. These connections are exactly the same, only using ADO DSNs instead of ODBC. So we have one that uses Windows authentication, and we'll execute our select statement and disconnect. Okay, format 1, the same, using the username and password in a host variable. That also could be embedded statically. Format 2. All these formats are the same. Here's the Oracle format with the identify by clause, also supported in managed code. Okay. Format 3 is not supported. That's the connect with prompt. That's only supported for ODBC. Connect reset does the same thing as a disconnect. Now here we get to a few additional items. For format 5, in this example, we can get our connection information out of the app config file. If we look over here in app config, we can see there's a connection string section that we've added that has a connection name of my connection along with the connection string. So this will not use a DSN. It'll use this connection string here to connect. So this will read using the configuration manager class. We'll read this my connection out of the app config file, setting the connection string to the information that's in there. Now we can say connect to the DSN using that connect string. So there's no DSN necessary. It reads all the information it needs out of the app config. Okay. Format 6, it's the same thing, only here it's not reading the app config file. It's just embedded all that information directly in the connect statement. Okay. A few new things using exec ADO syntax. Because these are true managed code objects that are being done behind the scenes, connection object and transaction objects, we can share them with other languages. Here I have a C# class that I'm using, and we'll call into that, and this will actually create a connection to SQL Server in the C# and then pass it back to COBOL to use in our OpenESQL statements. Okay, so it creates a new connection called myConnect. Here we're going to execute the same query that we've been using in our other demos in COBOL. This is just how it's done in C#. And it will display that same information, condiments. So I got back the same results. When we return back to COBOL, we're going to return this connection as a parameter. Okay, so in COBOL we set this connection object to that, and now we have our connection that was created in C# in COBOL. In order to get this as the current default connection in COBOL, we used a bind connection statement. Again, this is exec ADO instead of exec SQL, and we're binding our default connection to this connection object. Okay, now we can execute our select statement as if we created the connection in COBOL, and we can disconnect using the same way. Okay, the opposite of that, we can create our connection in COBOL. Here we're connecting to the DSN, the ADO DSN. Okay, show that that's working. And now we use exec ADO get connection into the connection object. Okay, and the transaction into the transaction object. We can then pass these objects into C# and use this COBOL connection there. So we do that, and we call a method setConnect, passing these parameters. Okay, and now we create our command using the COBOL connection and execute it. So it's very powerful with these exec ADO for interfacing to other languages. You can share connections between them. Okay, and we return back to COBOL. OpenESQL allows you to have multiple active connections within a single application. These connections can be for the same database type or a completely different one, such as SQL Server, Oracle, or DB2. You can give each of these connections a unique name using the as clause of the connect statement. You can then change the current active connection by using exec/SQL setConnection to connect name prior to executing the statement associated with that connection. Connections and connection names are global to an application run unit, so a connection established in a main program is automatically available in any called subprogram of that run unit without the need to reconnect in each program. For multi-threaded native code applications, you can use the thread equals isolate directive in order to maintain a unique connection in each thread that is called. For multi-threaded .NET managed code applications, you would use the run unit class to keep ADO connections protected from other threads. Let's take a look at how these multiple connections work. Okay, we have a simple program here. This is a native code. This is supported in both native code and managed code. We'll just run the program. Okay, the first thing we do is connect to a SQL Server connection. This is the same one that we use. This is an ODBC connection. Okay, the next thing we do is connect to a DB2 connection. And notice we're using the as keyword here to give a name to each of these connections. So here we're connecting to DB2 using a DB2 ODBC connection. So we have two connections now in our program, one to SQL Server and one to DB2. First one, we want to set connection using the name. We set it to our SQL Server. Now we can execute statements against that SQL Server connection so that that's working properly. Okay, now we want to switch to DB2, so we set our connection to the DB2 one. Now we can execute statements directly against the DB2 database to show that that also works. So we're using two database vendors in one program. Okay, here we call into a subprogram that's in the same run unit. We see that we don't have any connect statements in this subprogram, and we can still use our connection names that were established in the main program to show that they are global. Here we set our connection to the SQL Server connection and execute against that to show that that works. So the connections are global, and multiple connection types can be done within the same application. A couple of useful tools that you can use to gain more insight as to how OpenESQL connections work are the Visual COBOL documentation in the Visual Studio Help System, or the Visual COBOL samples browser, where you can browse through and open up various samples. Let's take a look at each of these. Under Help, View Help. This is also available from the group, the main group for Visual COBOL. Under Programming, Data Access, Database Access. Under Reference, for OpenESQL, you can see all the embedded SQL statements. Here's the connect, showing you the various formats and examples of each. Okay. And the samples browser can be found under the Visual COBOL group as well, under samples. Okay. And that gives you a list. If you click on SQL on the left hand side, it will give you a list of all the SQL samples that are available. Under OE-SQL, these are the ones that you'd be interested in. There's a specific connect sample here that shows connections in native code. But looking through all of these would be beneficial. And you can open them directly in Visual Studio and run them. That brings us to the end of the Visual COBOL in a nutshell presentation of getting connected with OpenESQL. For more information on using OpenESQL and Visual COBOL, please watch the related presentations in this series. Thank you for watching, and happy programming.